All right, so today you're going to learn more about Chapter 7, which is interest rates, growth, decay, and inequalities. This lesson will require a calculator, so you either have your own graphing calculator that you can use, or I'm going to show you how to use the Desmos online calculator, which is what you can use for your next quiz. Okay, Chapter 7. Today's problems involve, like I just said, interest rates, growth, and decay. So here's some formulas that you need to be familiar with. On your next quiz, I will provide you the formulas, but I won't give you like the names or the information, so you need to know what each of those formulas stand for. So let's start going over the formulas and then we'll do some examples. This first formula called growth and decay, that one we're going to use when the problem is talking about like a population growing. So this one is like populations. So like when populations are growing or getting smaller, we're going to use this one here. And then this is some information that you definitely need to know. We'll get to it when we do an example. The next two formulas here, those are going to be when it talks about interest rate. So it tells you here interest. One's called continuous compounding. The other one's called regular compounding. So I'll show you how that works. Continuous versus just regular. And this is some information you need to be familiar with. And then finally, the last two formulas talk about appreciation and depreciation. And this one's going to be when it talks about like money or like money value. So for example, like homes usually like appreciate in value. So the older, the more time goes by, the more they're worth. So that's called an appreciation. Or like cell phones, they usually depreciate in value, so the longer you have a cell phone, the less they'll be worth. So these are the formulas that we'll use when it comes to money values of appreciation and depreciation. So now, let's just try an example, pick the right formula, and then use the calculator online to solve it. Number 1. The Crafts invest $3,000 at 7.2 interest compounded continuously. So it looks like we're going to be using this second formula here. Let me write it down. So these are the kind of questions that you will see on your next quiz with a calculator. Determine how long it will take their investment to be worth $10,000. So if you look at the continuous compound interest formula, A is the amount of money in the account, including the interest that you've learned. So like the final amount of money in the account after the interest. P is the initial investment. R is the annual interest rate. And you need to put it as a decimal. And then T is the time in years. So for number 1 here, the Crafts originally invest $3,000. That's called the principal, which is the initial investment principal. So let me put that right here. 3,000 times e to the r. R is the interest rate, and it needs to be as a decimal. So 7.2%, we need to change it to 0.072. That's the interest rate as a decimal. We'll change the 7.2% out of 100 to 0.072. T is how long it will take, so we're looking for T. How long will it take for the whole investment to now be worth $10,000, including the interest? So that would be your A value, your final amount. So that's how you're expected to do it on your next quiz. Make sure you show your formula. And now we need to solve for T before we put it in the calculator. So let's simplify this and solve for T. The way I would solve for t here is first get rid of the 3,000. So divide both sides by 3,000. So that would be 10/3 equals e raised to the 0.072t. Next, the way I would solve for t now is I would change this exponential function into a logarithm function, or change it from exponential form to log form. So log form would be, since the base is e, it's going to be natural log of 10/3 equals 0.072t. And finally, the last thing we need to do to solve for t is just divide both sides by 0.072. So I'm going to have t equals natural log of 10/3 divided by 0.072. Notice how I showed my work. You have to show your work on the quiz or you just won't get any credit. Not that you have this, now you do need to put it in the calculator because on the quiz it'll just be fill in the blank and you're just gonna have to like fill in the blank for me. So let's put this in the calculator. And like I said, if you have your own graphing calculator, just use that. Put it in the graphing calculator. If you don't have a graphing calculator, let's use the Desmos online calculator. Okay, so hopefully the video is working now. All right, so number one, I need to show you how to type this into the calculator. If you have your own graphing calculator, obviously just do it by yourself. But if not, you can use the online calculator at desmos.com. So okay, you need to go to desmos.com. At the top where it says math tools, we need to switch to a scientific calculator. And then we need to go to the function thing. So here is desmos.com. We don't need a graphing calculator. What we need is go to math tools and switch to scientific calculator. Once you're here, we need to switch the, I don't know, the keyboard or wherever this is, from main, switch it to function. Okay. Now we need to type in number one. We're trying to do the natural log of 10/3 divided by 0.072. So right here, I'm going to do natural log of 10/3. Work with me. Where are my numbers? What do I want to do? 10/3, I guess. So I went back to main. Divided by 0.072. Enter. Okay. So now here the calculator has done it for you. 16.72. What do we need to round to? On the quiz, follow directions on what to round. I think I asked you to just round to like one decimal place, like the tenths place. For now, let's just do the hundredths place. Just follow the directions. So I'm going to go ahead and round to the hundredths place here. So 0.72. And that's what I'm going to write down here. So t equals. So I'm going to write t equals 16.72. And then the units will already be in the, for the quiz, you just need to put in the blank, fill in the blank. Don't put any units. The units will already be there. You just need to type in your answer, 16.72. So after 16.72 years, the Crafts will have $10,000 in their account if their money was compounded continuously at 7.2%. So that's the main lesson for today. So let's keep practicing some more. Number two, determine how many years it will take a sum of money to double in value when it is invested at 8.2% interest compounded every 3 months. So this one, is not a continuous compounded. This one is called compound interest, so the other formula, and that's the one I'm going to use. A equals P times 1 plus R over N raised to the NT. So P is still the principal amount, so how much you start with. A is still like the total amount with the interest at the end. So how much are we investing? How long will it take us to double? So on this specific question, we don't know exactly how much you started with, but we do know that however you started with, you want to double in value. So you want A to be twice as much as P. So I'm just going to start with like pretend P is like $1. So therefore we want A to be $2. Or if you want to, you can let A be $500 and then, or sorry, P be $500, and then you will let A be twice as much as that, so $1,000. It's easiest if you just go with 1 and 2 because we want to double in value. Next, I need to do times 1 plus the rate. Remember, you always change the rates to decimals. So 0.082. And now you need to divide by n. Here's what n is. N is the number of times the interest is compounded in a year. So if something is compounded every 3 months, that means that in 1 year, it will be compounded 4 times in a year. So compounded every 3 months, it just means that it's going to be compounded 4 times in a year because there's 12 months in a year. So that's what the n is going to be, 4. And I'm raising that to the 4 times t. Okay, then I'll do the same thing I did on number 1. I need to simplify this, change it to a log so that I can solve for t. So I'm trying to do this very quickly. I need to know what is 1 plus this mess. So calculator. 1 plus 2 divided by 4. That's 1.0205 raised to the 4t. So now I'm here. 2 equals 1.0205 raised to the 4t. Now I need to change this exponential equation into a log. So it's going to be log base 1.0205 of 2 equals 4t. And then I need to divide by 4. I'm just going to do 1/4 times log 1.02 equals to t. So notice how I'm showing all my work. Who was the question? I forgot how to pause this. Okay, so now we need to figure out how to type in this into that decimals calculator. Again, if you have your own graphing calculator, you can type this answer in the calculator as is. You just go to your to the scratch pad and you can type in that answer as is, because the graphing calculators will let you type in any base you want right there. So like 1.0205. So you can do that. But the decimals calculator won't do that. So here's what we'll need. It's one of the formulas from our last unit that I don't think we used last unit, but here it comes. When you have a log, so if you're going to be using the online calculator, you need to know this formula. When you have a log base b of anything, that's the same thing as natural log of a divided by natural log of b. Or you can just use log base 10 of a divided by log base 10 of b. So that's what I'm going to need in order for me to put this into the decimals calculator. So let me just change it right here. This is going to be 1/4 times, I'm going to do natural log of 2 divided by natural log of 1.0205. That's equal to t. So that's what I need to type into that decimals calculator to get the right answer if you don't have a graphing calculator. So let's try this. 1/4 times the natural log. Go to the function thing. Natural log of 2 divided by the net. What if I type? I think you can just type it ln. That probably works. So it works if you just type in ln. So anyway, so this is how you would use a decimals calculator to type in a log like number 2. So my answer, again, let's run to 2 decimal places to the hundredths. So let's go with 8.54. 8.54, and then it's years. The units will already be there on your calculator quiz. You're just typing in the blank. So that's number 2. The rest of these are going to be the same thing. Let's try number 3. Okay, 3 and 4 are both the exact same thing. One is increasing in value, the other one is decreasing in value. So I'll do one all the way, and the other one I'll let you I'll set it up. So number 3, a $175,000 home increases in value. So that's what I was telling you over here. That's called an appreciation. Money increases in value. So I'm going to be using this formula. V equals P, 1 plus R raised to the T. It increases in value at a constant rate of 6% per year. In how many years will the house be worth $250,000? So you can read here what they stand for, but P is the initial amount, so 175. V is how much is worth the appreciated value after a certain amount of time, so 250. 1 plus the rate is always as a decimal, so 0.06 raised to the T. Again, we need to solve for T, so let's simplify this. We're going to divide 250 by the 175. So I'll just use this one. 250 divided by 175. It reduces to 10/7 equals 1.06 raised to the T. Again, we got to change it to this exponential needs to be changed to a log. So let's put it here. Log base 1.06 of 10/7 equals to T. And like I told you, if you have your own little graphing calculator, you can just type this in as is, log 1.06 of 10/7. And it will tell you the answer. If you're using the decimals calculator, then you need to change this into the change your base formula. So we got to change it into natural log of 10/7 divided by natural log of 1.06. So let's type that into the decimals calculator. So divided by so it looks like after about 6.12 years. So remember, this was number 2. This is number 3. 6.12 years. Okay, so let's try number 4 the same way. I'm just gonna set up number 4, and then you just have to solve it by yourself so that we can save time and let you look at your test, like I said. So number 4 is just a depreciation formula. So this one, the value is decreasing. A car valued at 35,000. So first of all, I'm gonna use the depreciation formula, which just subtracts the R. A car valued at 35,000 depreciates 14% each year. In how many years will a car be worth 15,000? Okay, so the exact same thing as problem number 3. You can pause the video and work it out on your own, or just try this on your own using the graphing calculator or your Desmos. To save us time, I'm just going to tell you the answer. The answer key is online. So the answer is going to be T equals 5.62 years. Now, you have to show your work on the quiz or you will not get credit. So you can't just pull a Mrs. Garcia like this. You actually have to show all your work like I did over here if you want to get full credit. If not, you don't get credit. Okay, I'm just trying to save time. Number 5, let's show all the work because that one's different. Number 5 says, okay. Number 5, a certain type of bacteria population decreases from 326 to 40 in 120 minutes. So this is what the formula you'll use is the very first one called growth and decay. That's when you're talking about populations like people or bacteria or just items that aren't money. Populations increasing or decreasing. This is the formula we're going to use. Y equals C e to the KT. So the first question just says, find the value of K. According to the formula here, Y is the final amount. C is the initial amount, so how many people you started with, and Y is how many people are at the end. K is the constant rate. So if it's a population that is increasing, K will be something positive. But if it's a population that is decreasing, K will be something negative. And then it says T is the time. So number 5. A certain bacteria decreases from 326. So 326 is the original amount. 40 is the final amount. So it is decreasing. K is what we're looking for. Find K. T is the time. So 120 minutes. So this is our time in minutes. So the first thing we need to do is we need to solve for K, which is the rate of decay. And it will be negative because your stuff is getting smaller. So to find K, you're going to do what I've been showing you. You have to simplify this and change it to a log. So first, let's simplify 40 over 326. Go to your calculator or your Desmos calculator. 40 divided by 326. I don't know how to write that as a fraction. So let's just leave it as 40 over 326 equals e to the k times 120. Now we want to change it to a log. Since the base is e, we can just do natural log. So natural log of 40 over 326 is equal to k times 120. So finally, to solve for k, it's just going to equal to the natural log of 40 over 326, all of that divided by 120. So now let's use the calculator to get the value of k here. Natural log of 40 over 326. 120. So this K number here, the negative 0.01748, that's the rate of decay. Let's write it down as is. So negative 0.01748. So I'm going to write it down like that. So that's the value of K. Round to whatever decimal I ask you to round on the quiz. And if it is negative, make sure you put negative. So that was part 1. Find the value of K. Now we're going to do part 2 on number 5, which is how long will it take the bacteria to reach its half-life? Half-life just means like when will it be half the amount left? So to do that, we're still going to use the equation y equals c e to the kt. So half-life just means when will there be half amount left. So like I said, we can just put like 1 for the initial amount and then just put a half for the final amount. Or if you want to, you can still put the 326 for the initial amount and then divide it by 2 to get the half-life. I'm just going to go with 1.5 because that's simplest. Times e to the k. So we just found out that k value. So that negative 0.01748. And technically, you're not supposed to use rounded numbers. So we need to copy like the whole, like all of that. So on the calculator, we're just going to copy and paste it. For now, I'm just going to round it to that times t. And now I need to solve for t so I can figure out when it will reach the half-life. So this just needs to be changed to a natural log. So natural log of a half equals the negative 0.01748t. And then finally, to solve for t, let's just divide by this k number. So t equals natural log of a half divided by negative 0.01748. Okay, so like I was saying, here when we divide by this k value, we can't use a rounded number. We need to use all of it. So let's try to copy it from the calculator. Okay. So here we're going to do natural log of 1/2 divided by, I need to divide it by this whole decimal here. Control copy. Okay, so if you just do like Control C and then Control V to paste, it copies the whole decimal. And so now this is the exact answer rounded to 2 decimal places. So 39.65. You need to be, your answer needs to be exact. So let's put 39.65. On the quiz, you're just rounding to either the hundreds or the tens place. Just read the directions. Don't put any unit. The units will already be there. So for number 5, the units were in minutes. So this would be minutes. You just need to fill in the blank. Okay, so that's how you do these chapter 7 word problems. So make sure you show all of your work when you're solving these on the quiz. Obviously, you'll need the calculator, and then make sure you know which formula to use depending on the situation and know what all the little variables stand for. Like I said, on the quiz, I will give you the formulas, but I won't tell you the names of them. So you just need to know which one to use. And finally, last thing for today is example 6. It involves a inequality that you're going to solve by graphing. So for this, you will need a graphing calculator. So if you have your own graphing calculator, you just need to go to the graphs and graph these. You'll graph the left half of the equal sign for F1, and then the right side of the equal sign should be F2, and then you should be able to find the intersections. If you're using the Desmos calculator online, we need to go to a graphing calculator. So, Desmos. I'm gonna go to the graphing calculator this time. Okay, and we're still gonna graph it. We're still gonna do this under like the first equation, F1, and then this one under F2. So let's graph 5 raised to the 3x plus 6 minus 3. 5 raised. How do I raise it? Maybe like this. Yep. So go here and then raised to the 3x plus 6. Whoops. No, I want the plus 6 to be up here. Okay, so 5 raised to the 3x plus 6 minus 3. Enter. Okay, so the red graph is the first one. And now I need to graph log base 2 of x plus 4. Again, the decimals doesn't have the base thing, so we're gonna need to change. We're gonna need to change this to like natural log of x plus 4 over natural log of 2. So we need to type it like that. So natural log of plus 4 divided by natural log of 2. Okay, anyway, there we go. So now I've graphed the two graphs, and letter A says, when are the two equations equal to each other? So when are the two graphs equal to each other? They are equal to each other at the intersections. We only care about the x value. So right here, we only care about the negative 3.875. So let's write that down. So at x equals negative 3.875. And there's one other intersection. At x equals negative 1.7703. So you just write your answers in terms of x. So here they are, x equals negative 3.875. And then the other one was x equals negative 1.703. And Pritam question.
Oh, yeah. In the Desmos calculator, I think I figured out how to do bases.
Oh, then show us.
Yeah. So if you pull up the little like keyboard thing in the bottom, and then you press ABC, there's like a base B next to the like numbers.
Do you see it on my screen?
Yeah, on your screen.
This one?
Like, yeah, right there.
Okay.
So if you like type in log and then like you press that.
That's the wrong one. This one?
Yeah. And then now if you type like 2, yeah.
Okay, so I think Pritam just taught us how to do this. So yeah, that's perfect. Thanks. So if you're watching the video, now you know, thanks to Pritam, how to type in a base. Does it work? Did you try it on the scientific calculator also?
Oh no, I just like figured it out now.
Okay. So maybe now y'all can go play with the scientific calculator and see if it takes the little base as well. So we don't have to keep using that change of base formula. Thank you. Other question or Barack?
Yeah, you can also, on the scientific calculator, you can hit functions and it'll give you an option to do the same thing.
Okay, let's find it. So I've never used decimals before because we always have a graphing calculator available in the room, but so let's see if it works. So function.
So if you want to see, it should have, yeah, ln and log right there.
But then how do you do the subscript for the base?
And then there's, my screen says advanced. Like, if you have main ABC function, mine says advanced as well, so I don't know.
Oh, I don't know. So I guess if your screen is advanced like Barack's, then use it. I can't find it. Mine doesn't say that. Okay. Well, that's just on your own. You go figure it out. But thank you. Jessica, what was your question?
The TI Inspire calculators, when we like plug in these graphs, like it'll give us a rounded value of the x. So do you know how to like see the whole number so I can like round to the thousandths place?
Yes. Yes. So for that situation, once you graph it, log 2 of x plus 4. 5 raised to the... Once you find the intersections, minus x 4. Let me move it so you can see it better. Okay. So once you find an intersection, you should be able to like take the cursor thingy and put it above the number that you want to see more of. Yeah, so I want to see more of this because it's not really -2. So see how the little hand is open like that? Then if you press the plus sign, oh, come on. Plus sign? It should show you more. How come it's not showing me? Oh, it's because I forgot to put the -3. Okay, there we go. Okay, now it's showing me too much. But anyway, so if you take the cursor to where you want it, to what you want to see, you can press the plus sign to show you more decimals, or you can press the minus sign to show you less decimals. So
Okay, thank you.
yeah, just practice it. Okay. All right, so finishing number 6. Now I just need to figure out letter B. When is the exponential graph less than the log graph? So I have the pictures here drawn already. When you're trying to figure out stuff like that, what I like to do is I like to divide the graph into sections. So there was 2 intersections. So first, I'm going to look and analyze the graph before the first intersection. Then I'm going to analyze the graph in between the 2 intersections. And then finally, I'll analyze the graph after the intersection. Pritam, did you have another question?
Oh, no, sorry.
Oh, just forgot to put the hand down. Okay. So here goes. So I guess let me start over here on the right. So after the intersection of -1.703, if you look at the graph from top to bottom, you'll see the blue exponential graph first, then you'll get to the log graph. So after the intersection, that means that your F1 is greater than your F2. Or in other words, the exponential is greater than the log after the intersection. Because if you look at the graph from top to bottom, you'll see the blue one first, and then you'll see the log. So same thing. In between the 2 intersections, if you look at the top to bottom, you see the log graph first, which is the red one, and then you'll see the exponential. So that means that in the intersection, your, let's just call it F1, is less than F2. So your exponential is less than the log. And you can see the same thing on like the decimals thing. So same situation, like here you see the log first and then the exponential. And then finally, there's one more section. Before the first intersection, if you look at the graph from top to bottom, you first see the exponential and then you see the log. So that also means that F1 is greater than F2. Now we just need to answer the question. Letter B, when was the exponential graph less than the log? So F1, which is the exponential, was less than the log in between the intersections only. So we're going to put between -3.875 and -1.703. Brackets to show that it's inclusive, or if you're doing set notation, you can just do the same thing, but with set notation. These are for response on the quiz next week. So you can just choose either interval or set notation, or just follow directions if I ask you for interval. So that's letter B. Now the one you have to be very, very careful with is letter C, where it says, when is the exponential greater than? So for that one, there's going to be two answers. Let me start with the easy one. After the intersection of negative 1.703, that the exponential graph is greater than the log. So for sure, after negative 1.703 to infinity. Or you can write it this way. That's for sure. But then also, here's where you have to be careful with. The exponential graph is also greater than the log, technically like from negative infinity up to the intersection, but the problem is you can't just put negative infinity up to the negative 3.875 because the log function doesn't have a domain of all real numbers. Like this log function doesn't go past below negative 4 because that's where the asymptote is at x equals negative 4. So this log function has a asymptote at x equals negative 4. So therefore, when you write down when is the exponential greater than the log, you actually have to start it at negative 4 instead of negative infinity up to the intersection. Definitely on the test, and I will mark it wrong, or a quiz if you put negative infinity. So again, do not put negative infinity because your log graph doesn't go to negative infinity. It stops at negative 4. Use a parentheses here at negative 4 because that is the asymptote and you can't include it. And then if you want to use set notation, you would just go with negative 4 less than or equal to negative 3.875. So that would be set notation. So now I'm going to stop the video, but your homework for tonight is to do the worksheet that's attached to this. So here you have some practice, and then the second page is just more, or the third page is just word problems. Practice those. Let me stop this video.